Imagine a colossal power plant, the largest of its kind in Europe, now right at the very epicenter of a military conflict.
It's hard to even picture, really.
Exactly. And that's what's happening at the Zaporizhzhia Nuclear Power Plant, ZNPP, in Ukraine. This is, well, it's the first time in history that a civilian nuclear power plant has faced a crisis because of military action, and it raises a lot of urgent, unprecedented questions.
Absolutely unprecedented.
So in this deep dive, our mission is really to cut through the noise. We'll pull out the most critical insights from a Fukushima veterans' experience, detailed reports from the International Atomic Energy Agency, the IAEA, and expert analyses of the plant's design.
I really want to understand what's truly at stake here.
Yeah, what are the unique threats? And maybe most importantly, the concrete steps the international community is taking and maybe should be taking to prevent a potential disaster.
Right.
We'll look at everything from the plant's, well, surprisingly robust safety features to the incredible pressure on its operating staff.
And see how lessons from past nuclear events are actually shaping the path forward now.
Okay, so to really grasp the stakes, you have to appreciate the sheer scale of ZNPP. This isn't just any facility, is it?
No, not at all. It's Europe's largest nuclear complex. It has 6 reactors. Typically, they supply almost half of Ukraine's nuclear energy.
Wow.
Yeah, and about a fifth of all its electricity. It's a massive, absolutely critical piece of national infrastructure.
And it's been under military occupation since, early March 2022.
That's right. And that's the core of what makes this situation so unique, so dangerous.
We've seen shelling reported by both sides, causing huge international alarm. I mean, we saw that stark example on September 5th when the last working reactor was disconnected from the grid. That immediately sparked comparisons to, well, the nightmare scenario, Chernobyl in '86.
And those comparisons are natural, of course, but it's really crucial to understand the differences, the nuances.
Yeah.
The IAEA did conduct a critical visit in late August. And while Director General Grossi's reports were, I'd say, surprisingly positive regarding damage to some areas like low-level radioactive waste and unused fuel storage.
So not an immediate external radiation threat from those.
Correct, according to that initial assessment. But, and this is a big but, the agency also stressed that its operational role must be significantly expanded to mitigate the consequences of any kind of event, whether it's accidental or, intentional.
Okay, so let's peel back the layers then. Let's understand the actual threats versus the plant's safety features. Because the possibilities, they really range from minor incidents all the way to, well, catastrophe.
They do.
But here's a critical distinction, right? When we hear nuclear plant in conflict, many people immediately jump to Chernobyl, understandably. But ZNPP is fundamentally different.
That's such a vital point to make. Unlike Chernobyl's RBMK-type reactors, ZNPP uses newer Soviet-designed VVER reactors.
Okay.
And these VVERs are engineered differently. They're designed to automatically shut down if cooling water is lost. And they're encased in incredibly robust containment structures. We're talking 5 feet of heavily reinforced concrete.
5 feet. That's substantial.
It is. And crucially, there's no graphite to burn. That was a catastrophic factor in the Chernobyl explosion, the graphite moderator catching fire.
Right, the graphite. I remember that.
ZNPP doesn't have that issue. Plus, the spent nuclear fuel pools, they're located inside the containment building. That's another layer of protection.
Okay, so that addresses the Chernobyl comparison. How does Fukushima fit into this picture then? What can we learn from that disaster when looking at ZNPP?
Well, the Fukushima explosions, for instance, they were caused by hydrogen gas. It was a byproduct that built up outside the reactor core itself, leading to damage to the buildings.
Ah, so hydrogen explosions in the buildings, not the reactor itself exploding.
Exactly. Chernobyl, conversely, was a direct react explosion. So this distinction highlights that ZNPP's VVER design actually offers inherent safety advantages in certain accident scenarios compared to both of those terrible events.
So if the reactors themselves have this inherent robustness, where do the most pressing threats actually lie? What are the main vulnerabilities in this specific unprecedented situation?
I say the most conceivable, the most immediate threats concern the Independent Spent Fuel Storage Installation, the ISFSI.
The ISFSI, okay.
Back in 2017, the plant had over 3,300 spent batches of nuclear fuel rods stored there. Now, the storage canisters themselves, they're designed to be extremely robust. But the ISFSI facility itself, it isn't inside a containment structure like the reactors are.
Ah, okay, so it's more exposed.
It's more exposed.
Right.
Which means severe damage to one or more of those canisters could impede access to the facility. And that could then complicate the crucial cooling water supply, not just for the spent fuel itself, but potentially for the operational reactors, too.
And a reliable power supply. That's always the lifeblood for any nuclear plant, isn't it? Losing external power, especially in a conflict zone, that just sounds like a complete nightmare scenario.
It absolutely is. If external electrical power were lost, yes, the emergency diesel generators, the EDGs, they're designed to kick in.
Okay, backups.
Backups, yes. But here's the catch. They need continuous diesel fuel replenishment for any kind of long-term outage.
Right.
And that logistical challenge becomes incredibly complex, incredibly perilous when you're in the middle of a combat zone. How do you reliably get fuel trucks in?
Yeah, exactly. And beyond the technical failures, there's the human factor, too. You mentioned the staff earlier.
Yes, the human factor is paramount. Reports consistently highlight operator fatigue, extreme stress, and frankly, profoundly low morale. These are really serious concerns for safety.
Which is terrifying when you think about the precision and vigilance required to run a nuclear plant safely.
Absolutely terrifying.
Yeah.
A military miscalculation, or even an intentional hostile act. Those are significant threats alongside potential technical failures or human error under duress.
That human element, it's maybe one of the most insidious threats here. Which brings us to lessons from past events, especially Fukushima. You mentioned Charles Casto, who led an international team after the 2011 disaster. He offers some critical guidelines for managing these extreme crises.
He does. His insights are incredibly relevant. First, he emphasizes that leaders absolutely must imagine the unimaginable. Prepare for the worst-case scenario, even if it seems unlikely.
Don't assume it can't happen.
Precisely. Second, actions must be implemented faster than the progression of any accident. Speed is critical.
Get ahead of the problem.
Get ahead of it. Third, organizations have to rapidly expand their response capabilities. You need to scale up quickly. And finally, leaders must find a way to act effectively in the fog of war, despite all the chaos and uncertainty.
And if we connect that directly to ZNPP right now, what's Casto's takeaway for the current situation?
He makes a very clear point. It's kind of too late to worry about the hostile takeover itself. That's happened. The focus now must pivot entirely to managing the ongoing crisis.
Okay, crisis management mode.
Exactly.
Yeah.
And the IAEA, in particular, really needs to expand its operational role, directly applying those lessons from Fukushima, especially around transparent communication and rapid mitigation strategies.
On that point about communication, what was the biggest takeaway from Fukushima regarding information flow during a crisis? How crucial is that for ZNPP?
Oh, it's absolutely vital. A major painful lesson from Fukushima was that a vacuum of accurate information just fueled global fear. It led to some irrational decisions, and it significantly slowed down effective response efforts.
So misinformation or lack of information is actively harmful.
Actively harmful. Establishing a single trustworthy data source is paramount in these situations to provide clarity amidst the chaos and the rumors.
Right. Now, the IAEA, they've compiled what they call 7 indispensable pillars for nuclear safety and security during armed conflict. And the reports tragically state that the situation at ZNPP has compromised all of them, every single one.
In stark assessment.
Let's start with the most fundamental concern. Pillar 1, the physical integrity of the plant itself. What did the IAEA teams actually witness on the ground regarding damage?
Well, the IAEA observed extensive and direct shelling impacts. The nitrogen-oxygen station was hit, external power supplies, the plant's fire station, the wastewater station, even transitional galleries like overpasses used by staff.
So widespread damage to auxiliary buildings.
Widespread. Shelling also damaged laboratory and chemical facilities, a turbine lubrication oil tank, roofs of buildings, including the one storing fresh fuel and solid radioactive waste, and even the training building.
And the military presence.
That's another huge breach of physical integrity. Military equipment, including armored personnel carriers and trucks, wasn't just on site, it was found inside critical operational areas like the turbine halls and repair zones. Over 40 military units stationed at the ZNPP.
Inside the turbine halls.
Yes, this isn't just about having soldiers nearby. It's a fundamental breach of nuclear safety principles. It turns what should be a civilian facility into a potential military target, and it severely complicates any emergency response.
Yet, despite all this, the plant staff reported radiation levels as normal?
Remarkably, yes, according to the
Why?
IAEA report based on staff information at the time. But the damage itself is undeniable and deeply concerning.
Okay, so that's the physical structure. What about Pillar 2? The functionality of the safety and security systems themselves, how have they been compromised?
Well, as we mentioned, shelling incidents directly triggered emergency protection systems to activate and force the plant onto backup diesel generators. That alone shows the systems are under stress. But more fundamentally, the military presence on site actively undermines the designed physical protection system, while the Ukrainian staff confirmed that the core safety systems were operational.
Like reactor shutdown systems.
Exactly. But the security functions, like guarding the perimeter, access control, those have been completely taken over by the Russian military command.
So the people who design and normally run the security aren't in charge of it.
Correct. And there's also an expert group from Rosener-Goatom, the Russian state nuclear company, present on site, advising plant management. This creates a very complex, potentially conflicting chain of command.
That must create just an almost unbearable strain on the Ukrainian staff. Which brings us straight to the third indispensable pillar, the operating staff's ability to fulfill their duties. What's the human cost and risk here?
The IAEA describes the situation for the Ukrainian staff in stark terms. Working under unbelievable pressure with very low morale, they deemed it not sustainable and carrying a significant risk of increased human error.
You just can't operate under that kind of stress indefinitely without mistakes happening.
Exactly. And imagine the psychological toll. A staff member was actually injured in shelling near the dry spent fuel storage area.
Yeah.
That's a constant, terrifying reality for them.
Absolutely.
Plus, staff access to the main on-site emergency crisis center has been restricted by the military. They've had to set up an alternative center.
Which the IAEA noted was inadequate, right? Lacking independent power, ventilation.
Precisely. Not fully functional. And there are significant staffing shortages across the board. Physical protection is 40% vacant. The fire brigade is down by 80 personnel. Emergency preparedness and response is short over 300 people.
Huge gaps.
Huge gaps.
Yeah.
And while operational decisions are technically still made by the Ukrainian managers, the military personnel explicitly limit their access to certain critical areas, like the cooling ponds.
Unbelievable. Okay, pillar 4. Secure off-site power supply. We know how critical this is. What's the integrity of that lifeline at ZNPP?
It's precarious. ZNPP normally has 4 main 750 kilovolt external power lines, but several have been damaged or disconnected due to the fighting.
4 main lines.
Yes. For example, on August 5th, shelling near an electrical switchboard caused a major power shutdown, disconnecting 1 reactor unit and forcing it onto those emergency diesel generators we talk about.
Right.
Then later, on August 25th, the ZNPP temporarily lost power from its last operational 750 kV line, not once, but twice in one day. It had to rely on a less robust 330 kV line from a nearby thermal power plant.
So they were down to a backup line from another plant.
Exactly. And at one point, all 6 reactor units were disconnected from the external grid entirely.
Wow.
Now, while the EDGs, the diesel generators, can theoretically operate for about 10 days, and they have around 2,250 tons of diesel fuel available on site.
That sounds like a lot.
But the critical challenge, as we said, is getting more fuel delivered reliably during the conflict. And another problem, spare parts for damaged high-voltage electrical equipment are often tailor-made. They require long lead times for manufacturing and repair. You can't just get them off the shelf.
So repairs are slow and difficult, even if you can get the parts. Okay, next pillar, number 5. Uninterrupted logistical supply chains. This sounds like it's directly related. How are they holding up for general maintenance and supplies?
They're severely disrupted, as you'd expect. It's incredibly challenging to acquire spare parts and just basic consumable materials needed for routine maintenance.
So things are getting delayed.
Yes. While the IAEA reported that no critical safety systems were currently out of service due to a lack of parts at the time of their visit, crucial overhaul maintenance for things like the emergency diesel generators themselves and the main circulation pumps has been delayed.
That can't go on forever.
No. And the delivery of spare parts and diesel fuel is described in the reports as extremely difficult. It often relies on unpredictable case-by-case personal arrangements rather than any kind of reliable established system. Even maintaining the fire trucks is a constant struggle.
It sounds incredibly fragile. Okay, pillar 6. Effective on-site and off-site radiation monitoring and emergency preparedness. What's the status of these vital functions?
This is deeply concerning. Shelling on August 6th damaged communication cables for the radiation control system, impacting the sensors. In fact, the entire radiation monitoring system was apparently down for about 24 hours in late August.
Completely blind for a day.
Seems so. And critically, radiation measurements at the southern part of the plant's perimeter are currently unavailable because of cable damage. They just can't get the readings.
So there are blind spots in monitoring.
Yes. And as we touched on, the main on-site emergency center, the hub for crisis management, is inaccessible. It's occupied by the military. The alternative center they set up is completely inadequate.
And off-site.
Perhaps most alarming, the IAEA stated that off-site emergency preparedness and response arrangements are simply not provided.
Wow.
They're not functioning. The plant cannot even make essential recommendations to protect the public.
Like sheltering or evacuation.
Exactly, because there's a complete lack of communication with the local government authorities responsible for implementing those measures.
That's terrifying. Which leads us straight to the seventh and final pillar, and perhaps the most fundamental in any crisis, reliable communications. How has that fared at ZNPP?
It's been severely impacted. Communication between the plant ZNPP and the Ukrainian national regulator, SNRIU, has been described as severely affected and very limited and fragmentary since March 2022.
How are they even talking?
They're relying mainly on vulnerable mobile phones and email. Not secure, not reliable. Ukrainian regulatory inspections. Impossible on site. Any oversight has to be conducted remotely, which is obviously limited. This lack of reliable internet or satellite connectivity is a critical shortcoming. It hinders any effective emergency response and coordination, not just locally, but regionally, nationally, and internationally too.
So every single one of the IAEA's 7 essential pillars for safety and security in conflict
Compromised or completely violated.
Yeah. That's an incredibly bleak picture. All these compromised pillars and immense risks. What proactive measures and recommendations are being put forward? How can the international community try to step in or mitigate this?
Well, there are several ideas being discussed. The international nuclear community is seriously considering establishing formal protection zones around nuclear plants in conflict areas.
Like a demilitarized zone.
Essentially, yes. Maybe a 10-mile zone for immediate hazards, and perhaps a larger, say 50-mile zone, for ingestion pathway hazards like contaminated food or water. This draws directly from lessons learned during the Fukushima response. Lithuania has even volunteered peacekeepers for such a concept.
Interesting. And diplomacy.
Diplomacy is, of course, of paramount importance, as the IAEA puts it. One idea is that the IAEA could try to mediate a specific agreement between Russia and Ukraine focused just on the plant's safety and security, perhaps similar to how the Black Sea grain export deal was brokered.
Maybe involving a neutral third party like Turkey again?
Potentially, yes. Finding some diplomatic off-ramps specifically for the plant is seen as crucial.
Okay. And what about getting better at detecting potential threats, radiological threats, and mitigating them? What technological or strategic responses are being considered?
That's a huge focus. There's an urgent need for more radiation detection instruments, both remote sensors and local ones. The IAEA should also probably prepare for large-scale aerial radiation monitoring capabilities.
Like using drones and aircraft.
Exactly. Leveraging satellite thermal imaging, drones, aircraft, just as was eventually done quite effectively during the Fukushima response. Furthermore, data from other regional nuclear plants and even private monitoring networks. There's one called Save EcoBot. The data should be made readily public.
Like the EU's online radiation map system.
Precisely. Creating a single, trustworthy, publicly accessible data source is paramount to counter misinformation and prevent the kind of panic we saw fueled by the information vacuum during Fukushima.
Beyond data and detection, what about physical mitigation strategies, things we could actually do to protect the plant more effectively in this kind of scenario?
Well, one concrete idea is establishing a neutral staging area, somewhere safe but accessible. Think of it like Japan's J-Village, which became a crucial hub after Fukushima.
What would you put there?
You'd stockpile essential equipment that could be quickly airlifted to the site if needed. This could include specialized pumps, generators, communication gear, even something as basic as large amounts of sand.
Sand. Why sand?
Sand could potentially be used, for instance, on the ISFSI pad, the spent fuel storage area, to help reduce radioactive emissions if some of those canisters were severely damaged. It's a potential mitigation technique.
I see. A practical measure.
Another quite powerful idea being floated is housing a standby group of experienced nuclear operators from a neutral country in this staging area. They could be ready to take operational control of the plant if the regular ZNPP staff had to be evacuated.
Like a rapid response team for operations.
Exactly. Similar in concept to France's nuclear rapid response force, foreign, but international and deployable under IAEA auspices perhaps.
This whole ZNPP situation, It's unfortunately revealed new vulnerabilities. It seems like it's opened the door to entirely new, dangerous military strategies targeting critical infrastructure. That implies the IAEA needs to prepare for similar events globally, doesn't it?
It absolutely does. This is a wake-up call. The IAEA needs to anticipate and prepare for similar events at other nuclear facilities worldwide and work proactively to prevent harmful acts at other nuclear power plants that could be caught up in future conflicts.
So, what specific direct recommendations has the IAEA made to those currently in control at ZNPP? What are they telling them to do right now?
The IAEA has been very clear and direct in its reports. Their recommendations include stop all shelling affecting the plant immediately,
Mhm.
operate the physical protection systems as they were originally designed, not under military control, remove all military vehicles and equipment from within the plant buildings.
Get the military hardware out of the turbine halls.
Precisely. Also, reestablish a supportive and less stressful work environment for the incredibly strained Ukrainian staff. Ensure the redundancy and reliability of the off-site power supply. Facilitate the logistical supply chains for parts and fuel. Restore all the emergency response functions, including the proper crisis center and communication links. And ensure reliable, redundant communication channels are reestablished with the regulator and the outside world.
A pretty comprehensive list of urgent actions.
Urgent and essential.
Now, despite all these immense challenges, what's the status of the core nuclear safeguards? The monitoring to prevent, say, nuclear materials from being diverted. Is the IAEA completely in the dark on that front?
No, thankfully not completely.
Yeah.
The IAEA has actually managed to continue implementing its safeguards mandate in Ukraine despite the war. They've conducted, I think, 12 verification missions across the country, and they continue to use remote monitoring systems where possible, including a ZNPP.
So they're still getting some data.
Yes, although there have been interruptions in data transmission from ZNPP at times. But the crucial insight here, the key takeaway from the IAEA's safeguards perspective, is that so far, they have found no indication of nuclear material being diverted for non-peaceful purposes or any other immediate proliferation concern related to Ukraine's nuclear material.
That's at least some reassurance amidst all the other dangers.
It is. It's a testament to the agency's efforts and the professionalism of the Ukrainian operators under incredibly difficult circumstances.
Okay, before we wrap up on ZNPP specifically, let's briefly touch on Chernobyl again. Russian forces withdrew from that site back on March 31st, 2022. What's the update there? Has it recovered?
Well, at Chernobyl, the situation has stabilized significantly since the withdrawal. Communications have been restored, normal staff rotations have resumed, and radiation monitoring has been fully reestablished.
And the radiation levels after the occupation, there were concerns about stirred-up contamination.
Yes, there were. An assessment of environmental samples collected after the withdrawal showed generally very low radiation exposures for the remaining personnel, typically in the range of 0.3 to 0.6 millisieverts over periods of 14 to 35 days.
How does that compare to normal background radiation?
It's well below the average global background radiation dose people receive annually. The exposure was primarily from external gamma radiation from cesium-137 left over from the 1986 accident. While there was significant damage reported to laboratories and monitoring stations at Chernobyl.
Looting and vandalism, I heard.
Yes, significant damage. But the critical insight from a health perspective is that no significant health effects are expected for personnel due to radiation exposure during or after the occupation period.
That's good news, relatively speaking. And other Ukrainian nuclear facilities, the ones not occupied.
The other major nuclear power plants like South Ukraine, Rivne, and Kamysky NPPs have continued to operate safely throughout the conflict, according to the IAEA and the Ukrainian regulator. Although there have been deeply worrying instances of missiles overflying some of these sites.
Flying missiles over active nuclear plants.
Extremely dangerous. Other facilities like smaller research reactors, radon waste disposal sites, and the Kharkiv Institute of Physics and Technology have also faced some minor damage from fighting nearby, but again, without reports of significant radiological consequences so far.
And the IAEA is actively providing assistance to Ukraine across the board, right? Not just monitoring ZNPP.
Yes, absolutely. They're providing remote assistance and expert advice. They're also delivering essential equipment. They've managed to address about 40% of Ukraine's priority requests for safety and security equipment so far.
So there's still a significant need.
Yes, the IAEA estimates around 10 million is still needed just for the highest priority items requested by Ukraine. They're also conducting crucial in-person missions to various sites, including Chernobyl and the operating MTPs, to provide direct support and assessment.
But logistics must still be a nightmare.
Huge challenges remain in logistics and procurement, getting the right equipment to the right place at the right time during an active war. It really underscores the pressing need for continued coordinated international cooperation and financial support for Ukraine's nuclear safety and security efforts.
Okay, so let's try and pull this all together. What does this all mean for you, the listener, and, well, for the world? The situation at the Zaporizhzhia nuclear power plant is, as we said, truly unprecedented. It's a stark, frankly sobering reminder of just how fragile the intersection is between geopolitical conflict and this vital, incredibly high-stakes infrastructure.
It really is. But what's also remarkable, I think, and maybe even a source of quiet inspiration, is the sheer resilience you see from the Ukrainian plant staff, operating under just unimaginable pressure,
Day in, day out.
day in, day out, and also the tireless, very pragmatic efforts of the IAEA
Yeah.
trying to maintain some semblance of safety and security in circumstances they've literally never encountered before.
The detailed insights, like from the Fukushima veteran Charles Casto and the IAEA's own framework, those 7 indispensable pillars, they don't just list the problems, do they? They give us a concrete way to understand the threats, and crucially, they point towards potential pathways for mitigation.
Exactly. It's not just about the dangers, it's about understanding the specific vulnerabilities and what can or should be done.
From the robust design of the ZNPP's VER reactors, which is a positive point, to the absolutely critical, almost existential need for reliable communication and secure supply chains, which are clearly failing right now. Every detail just underscores the sheer complexity and the urgency of this situation.
It's a multi-layered crisis.
This deep dive, I think, reveals not just the dangers, which are immense, but also the ingenuity, the dedication, and frankly, the sheer human will that's involved in trying to prevent a nuclear catastrophe right in the middle of a war zone.
Yeah, the human element on both sides, the danger and the dedication is key.
So as we look to the future, this situation really forces us to ask an important question, something for you to think about. What broader fundamental lessons does this ZNPP crisis hold for global nuclear safety and security, especially in what seems like an increasingly uncertain world? And how can we collectively adapt our international frameworks, our treaties, our response mechanisms to better protect these critical assets from similar threats down the road?
That's the big question, isn't it? How do we prevent this from becoming the new normal?
Exactly. It's definitely a thought worth mulling over.